Hello everybody, today we are going to solve this physics question here today. Determine the stopping distance for a car with an initial speed of 95 kilometers per hour and human reaction time of 1.0 seconds for an acceleration of -8 meters per second squared. So this was actually a question that I had on my first test in grade 12 physics, but this is a pretty simple question and this might be something that you could even expect in grade 11 physics. So let's go through how to do this question. So first, let's get an idea of what's happening. So we have a vehicle that is traveling with an initial speed of 95 kilometers per hour, and this vehicle is going to continue traveling at this speed for 1 second because we have a reaction time of 1 second. So after 1 second of traveling at this speed of 95 kilometers per hour, the vehicle will start to decelerate at a rate of 8 meters per second squared. So there are two parts to determining the stopping distance. So part one will be the reaction time distance, because it takes some time to react and the vehicle is traveling at a constant speed during this time. And then the second part is the deceleration distance, because once the foot is on the brake, the vehicle starts slowing down, and the vehicle doesn't just immediately stop once your foot is on the brake pedal. It travels some distance. So we have to calculate both of these distances and add them together, and that will be the answer to this question. So let's solve number one first. Let's take a look at what we have available. So here will be our variables. We'll have an initial velocity, we will have a final velocity, there will be some amount of time, there will be a value for acceleration, and there will be a distance value. So let's write what we do know and what we don't know. So what is the initial velocity during the period of reaction time? Well, that will be 95 kilometers per hour. So let's write down 95 kilometers per hour. But this would be better if we had this in meters per second. It'd be easier to work with. So let's convert this into meters per second. So there are 1,000 meters in 1 kilometer. And then over here, kilometers cancel out. And in 1 hour, there are 3,600 seconds. So over here, hours cancel out. So we are left with meters per second if we multiply 95 times 1,000 divided by 3,600. So this value ends up becoming 26.4 meters per second. Okay, so our final velocity is the speed of the car right before we start decelerating. So what is that going to be? That is going to be this same value here, because right now we're looking at the period before the foot gets on the brake pedal. So before your foot is on the brake pedal, you're going to be traveling at the same speed. So that again is going to be 26.4 meters per second. Okay, how about time here? Do we know what the value for time is during the reaction time distance? Well, we do know what that is. That in this case is 1 second, because that's how long we're going to be traveling at this speed before our foot gets onto the brake pedal and the velocity starts changing. Okay, how about acceleration? So over here, the acceleration in this period is obviously 0. We're not going to put in -8 meters per second squared here, because this is the reaction time distance, not the deceleration distance. So we know that acceleration is the change in velocity divided by time, and both of these velocities are both the same. So if you're traveling at a constant speed, then acceleration is equal to 0. Okay, and how about x? We don't know what x is, but that's what we're solving for. So we only have one unknown here, so we could very easily solve for what this distance is. So we can use the equation, and this is something that you should know. Average velocity times time is equal to distance. And we can just plug this in directly. So what is our average velocity? We could do final velocity plus initial velocity divided by 2, or you could just put 26.4 directly, because if you're traveling at a constant speed, then your average speed is just going to be that speed. So times time is equal to x. So solving for x, let's put these values in. We're going to have 26.4 meters per second plus 26.4 meters per second divided by 2 times time is equal to 1.0 seconds. What do we end up getting? 26.4 meters. So we can see the units here are meters per second and meters per second multiplied by seconds. The seconds cancel out. We're left with just meters. Okay, so we could call this x sub r. So this is the distance that is traveled before we start reacting. So we solved the first part of what we need. So this is the distance traveled before our foot gets onto the brake pedal. Next, we have to solve for what distance does the vehicle go while our foot is on the brake pedal and we are accelerating at a rate of -8 meters per second squared. So let's solve the distance traveled while our foot is on the brake pedal. So we'll have all of these same variables again. We'll have initial velocity, we'll have final velocity, we will have distance traveled, we'll have an acceleration value, and there will be some period of time. So let's fill in these values. Let's see what we do know and what we don't know. So initial velocity, how fast is the vehicle traveling right at the moment that your foot gets onto the brake pedal? It's going to be the same as this initial velocity over here, 95 kilometers per hour, which we calculated to be 26.4 meters per second. And the reason that this is 26.4 meters per second is because when your foot first gets on the brake pedal, you don't start slowing down yet. Immediately, once your foot gets onto the brake pedal, we'll start slowing down at a rate of 8 meters per second squared. But right now, before that happens, this is still our initial speed. So what is going to be our final speed? Well, our final speed is obviously going to be 0 meters per second because that's when we come to a complete stop. So a complete stop is 0 meters per second, so that's our final speed. Okay, what about the distance traveled? This we do not know, and that is actually what we are solving for. Once we get this distance, we will add that to the distance traveled before our foot reaches the brake, which was our reaction time distance. We'll add both of these distances together, and that will be the answer to this question. All right, how about the acceleration? Do we know what the acceleration value here is? We do know what the acceleration value is, and that is given to us in the question. The acceleration is -8 meters per second squared. So -8 meters per second squared. All right, and how about time? Do we know how long this period is going on for? Is this 1 second? Well, probably not. This isn't going to be 1 second. The 1 second that was given to us in the question was the reaction time, so that was used in the first part over here. But this time here, right now, we don't know what this time is, so we'll leave that as a question mark. So one equation that you should know that can help you out over here is that acceleration is equal to the change in velocity divided by time. So if we take a look at this equation over here, which we should know, and we take a look at which of these variables we do and don't know, then there's only one unknown in this equation, which is t. We don't know how long this period is happening for. So if we use this equation and we isolate for t, which is the one unknown, then we have final velocity minus initial velocity divided by acceleration. So we can solve for t. Let's plug in these values. Final velocity is equal to 0 meters per second. Subtract initial velocity is 26.4 meters per second. And what's acceleration? Acceleration is -8 meters per second. So time ends up becoming 3.3 seconds. And the reason that this is positive is because this is a negative divided by a negative. So now, in this equation here, in these variables that we have here, the only unknown that we have is this x right here. So we can solve for this x using the same equation as before. Average velocity times time is equal to distance, because now we know the time. So let's do that. So we know that average velocity times time is equal to distance. So let's plug in everything and solve for x. So average velocity is equal to final velocity plus initial velocity divided by 2 times time is equal to x. So in our case, x is equal to, and let's plug in all these values. So what is the final velocity in the stopping phase? That's 0, because when you come to a complete stop, you're going to be going at 0 meters per second. Okay, what is the initial velocity? That was 26.4 meters per second. That's all divided by 2. Okay, and then we multiply that by time, and we found time to be 3.3 seconds. Okay, so our answer here becomes 43.6 meters. So to get the final answer to this question, we just add this distance together with this distance, because the distance traveled during the reaction time period and the deceleration period will be the total distance. So let's do that. So we have 26.4, and we could call this our D for deceleration. So our x total is just x reaction plus x distance. So our x total distance is just equal to, this one was 26.4 meters plus 43.6 meters. So x total ends up becoming 70 meters, and that is the final answer to this question. This question asked, determine the stopping distance for a car with an initial speed of 95 kilometers per hour and human reaction time of 1.0 seconds for an acceleration of -8 meters per second squared. That ends up being, you travel 26.4 meters before your foot gets on the brake. Then while your foot is on the brake and you're decelerating, you travel 43.6 meters. So in total, you travel 70 meters. So hopefully this video was useful to you. I'd love if you could share this with somebody if you think it might help them. And I hope to see you in the next video, so take care.